My name is Max Liu. I'm currently a PhD candidate at the Graduate School of Education at Harvard, doing research around AI education, media literacy, and stuff. And I proudly call myself a friend of the App Inventor community, so as all of you guys. So I'm really, really privileged to moderate today's session featuring the heroes behind the scene with App Inventors. So first of all, raise hand. How many of you think the world is a slightly better place because of App Inventors? Raise your hand. Okay, quite a few of you, huh? I wonder, for those of you who haven't raised your hand, what's the reason? Okay, you can talk. But those would have not been possible without those folks behind the scene and over there. Who are the teams working on App Inventors here? Raise your hand. Or community member and all that. You don't have to be affiliated with MIT if you contribute to App Inventor. Raise your hand as well. It's a lot of you. Let's give a round of applause for this really amazing community. App Inventor is not just a tool or a platform, it's really a community. Like they said, 30 million people, and it takes a lot of effort in building those. And today, my job is to sort of ask questions, to have those people who created this platform, this community, to share some of the story behind the scene, and also for you to think about who are those people building the tool that you're using today and these days. So let me begin by asking everyone to really quickly tell us your name. When did you first started engaging with the App Inventor Foundations and what you do now? Just as short as you can.
I'm Mark Friedman. I was there at the beginning and the invention of App Inventor, as well as the beginning and the invention of the App Inventor Foundation. I was at Google when App Inventor was originally created, and I'm actually now sort of semi-retired, but still working for the App Inventor Foundation.
I'm Natalie. I'm the executive director of the App Inventor Foundation. I started working with MIT App Inventor when I was I think, junior in college. I went to MIT for undergrad, and I was teaching in Barcelona, and it was just amazing. The students really engaged with it. They were learning computing in a way that they could create things that they could use. So I came back, I knocked on Hal's door, and I asked to do research with him. And that ended up with me staying here for like 10 years, doing a PhD, and now here we are.
Marisol Diaz, the program manager for MIT App Inventor, and I started as soon as Hal came back from sabbatical from making App Inventor, and I've been here ever since. Started off as administrative work with him, then as the project manager, and now program manager.
Hi, everyone. I'm Dr. Evan Patton. As I mentioned earlier, I've been at MIT App Inventor for 10 years, but even as a grad student, I worked on App Inventor because my interest was in mobile computing and how to apply interesting technologies to mobile computing, and I learned about App Inventor, found it to be a super exciting platform to disseminate my own research, and it was a great thrill to be asked to come and work here when I graduated. So.
Well, I'm listening to all of this and wondering if I belong in this seat. I joined App Inventor in November last year, so I'm 8 months in. My own background is in educational development, so I've worked across the world on curricula and connecting education to the world of work, early literacy, and technology in education, which kind of morphed into AI in education as that began to have a bigger and bigger influence. I met Natalie because I read her PhD thesis doing some work for UNESCO back in, I want to say that was like 2019. So when I was asked to be the lead author on the UNESCO AI competency framework for students, I said, I definitely want this person on the team. I hadn't met her before that, but we worked really, really well together. And I'm very fortunate now and agree with Evan that it is the best place to work and very mission aligned with me and my desire for equity and development. So I'm happy to be here, although a newcomer.
Hi, everyone. My name is José Dominguez. I first contributed to App Inventor through Google Summer Code back in 2012. And then I became a part of the team here at MIT. And a year ago, I rejoined through the foundation. So I'm an engineer at the foundation.
Hi, everyone. My name is Barreiro Pérez. I actually started in App Inventor as a user in 2014 in high school. I wanted to build an app and then a teacher suggested App Inventor. And then from there, I actually started contributing, I think back in 2016 or 2017. I was part in Google Summer of Code as a student, as a mentor, and then I also co-founded a platform based in App Inventor called Kodular. And then I also keep contributing to App Inventor.
Thank you. Kelly, by the way, the highest compliment you could give to a researcher is you read their PhD thesis. Not just,
So I've heard.
not just a paper or any paper, it's a PhD thesis. It's a lot of pages. And, okay, so when App Inventor was first created, when was that? Which year was that?
It started in 2008.
2008. We didn't quite know it's going to be the era of mobile internet yet, right? Or did we? Like, bring us back when it was first started. What problem were you trying to solve? And I'm also curious, how has that problem definition changed over time for the App Inventor?
Sure. So let me I'll start with a little bit of a story. So in 2008, this was maybe a year after Apple announced iPhone, and a little bit less than that when Android was announced. So very few people actually had, what we would call smartphones now. But it was the summer of 2008, and Hal was hanging around Google, as he sometimes did during the summers, talking to people, seeing what's going on. And I had known Hal from years before, and we were having lunch. At the time I was actually working on the Android team at Google in a completely different capacity. And Hal and I were having lunch, and he just said this thing, which was kind of amazing. He said, "What if kids could build mobile apps?" And I was just like, kind of just blown away. This idea that even adults didn't really have smartphones. But he had seen that this was going to become something where basically every kid was going to have this computer in their pocket. And what if they could build mobile apps? The idea being, what if they could be creators of digital technology and not just consumers? And what would this mean in terms of how it would change the way that they think about the world of technology? This was really exciting to me, and Hal was saying, well, he was going to create a research project and try and get a little bit of money from Google to do this at MIT. And I said, no, let's build this thing. Let's build it into a real product at Google. And then Hal got excited about that possibility, and that was the beginning of the App Inventor project at Google. Obviously, later, we said this would be a good thing to be open sourced, brought back to MIT when Hal finally went back to MIT. Evan came on, a few years later, and sort of the rest is kind of history. And now I've forgotten what the other question you asked.
No, you answered it perfectly. But it's now increasingly intuitive that if you have an idea, you can build it one way or the other, whether you use App Inventor or you prompt it out with ChatGPT or GenAI. It didn't feel quite obvious back then, right? What did it take it took a lot more resources to build apps back then. Was that the case?
Oh, yeah. I mean, one of the amazing things was that one of the things that I was working on Android before App Inventor was how can we get professional developers to be able to build apps, like build the libraries and the tools and the training and everything. I mean, it was even within Google, it was hard for Google engineers to build mobile apps. So how are we going to get kids to be able to do it? Like, that was just a fascinating technical challenge.
Right. And let's dive into that, because I think a lot of success of App Inventor is sort of the success of cutting-edge research in combination with sort of the real-world community. How did you make that happen? I guess the question for Evan, José, and those of you guys actually building out the thing, how do you make it so that it both allow people to build powerful things, but also doesn't take a whole 4-year education in programming before you can start thinking about it?
Yeah, well, it's a really interesting challenge. And we try to tackle it from a couple different angles. Right? So the first is obviously being at MIT, it's a world-renowned research institution, so we have access to a lot of students with really great ideas, and they're really motivated to do amazing things. I've had the privilege now of mentoring almost 100 students at MIT over the years. including people like Natalie, who, by the way, created what is now CloudDB in her master's thesis. And the idea, right, that we can engage with students who look at the world in different ways and really see opportunities, and then we work with them to start to build those opportunities into real solutions. But importantly, App Inventor is really thinking about what are the core building blocks you need to build something amazing. We don't know what the amazing things are that people are going to build. That's been one of the really fun parts of this job, is just seeing, like all of you who have built apps in this room and are going to be presenting, tomorrow, for example, like we didn't imagine what those apps would be, right? We gave you the building blocks, and it's your creativity that has really turned App Inventor into the success it is. My first project coming to App Inventor was making maps, right? So if you've used the map component in your project, that was my contribution when I first started here. I really wanted to make something interactive because I wanted to see how students would use it in really interesting ways. And so that was a great thing to see. But then the other part of it from the research side is really trying to structure what the studies look like, because we want to be informed on how people use the system and can leverage it to build apps. And so Lynn Turbach and I think Lynn is I saw him earlier, but there he is. Hi, Lynn. We did a study or some work back in like 2018, 2017, something like that, on the what are called the any component blocks, right? So in App Inventor, if you create a lot of components, you may need to manipulate multiple of them in a loop. And we recognized that through studying the actual projects people were building, that they were doing these really kind of poor design decisions. And that was because the tool wasn't good enough, right? And so by actually studying how students were using the tool, we were able to improve some of the capabilities and make it easier for them to build more expressive applications. And so that's really the power of what we're able to do here at MIT. But it's through all of the resources and the team that we've built that's actually possible. Jose, you want to add anything to that?
Yeah, from an implementation point of view, App Inventor is really a game of abstractions for us. So we put together these components and these blocks that encapsulate a lot of complexity. When you just simply have to drag and drop a component, but under the hood, there's a lot of stuff happening. So that is what makes possible to program at this higher level of abstraction. You don't need to know all of the details. So that is basically how things happen. And for us, it's a very nice problem to have, right? And some abstractions are good, and some abstractions are not so good. But we can iterate on those things.
One thing I learned that about the success of the App Inventor platform is it's not just those people building it, but they could really cultivate like a global community building it. I'm curious in hearing from our panelists, what do you think is the role of your community in the success of App Inventor, in the development of it? And we also have Diego, who he himself is sort of an example of someone who was part of a community member contributing to it, now building something quite spectacular based on the success of this. Do you want to share with us a bit of what you are doing and then your view on the role of community?
Yeah, I mean, I think that one of the coolest parts of App Inventor is being open source, as we all know. And to me, it's the fact that there is so much support from all the team here, Evan, Jose, Mark, and everyone else, that I basically had a bunch of ideas for App Inventor on how to improve it. And I was talking with Evan, actually, and I was able to kind of make a submission for Google Summer of Code. And then through his mentorship, I was able to deliver. So I think that the amount of support from the team is just what makes it better and eventually helps us to make it better later. But if I want to like maybe mention something that is about community as well, it's about building apps and the fact that of the community that they know about App Inventor and they can teach people what is App Inventor. I wouldn't be here if my teacher in high school didn't know about App Inventor. So I think that there are those two communities, the developers that we are here and also the teachers that eventually share about App Inventor, that just makes it eventually contribute to make it better and larger later on.
Yeah, we'll certainly delve into the teacher part of it in a little bit. But before we move on to other panelists, tell us a bit more about Kodular. How is it different from App Inventor? What does it do?
So basically, this started like 2017. We wanted to make, first it was like a learning project actually. So it was more like we were 8 people and we wanted like, oh, how can we actually improve and learn more about App Inventor and also like improve our skills? And we were like, okay, let's make like a little fork. And that eventually like grew a lot. And a bunch of other features that we have on top of App Inventor is like a different design in terms of on building the apps. But also we have advertising and monetization solutions that some maybe more professional users want to use later. However, we kind of collaborate quite tight and actually have like a feature that I will share later on in the papers that hopefully will get added to App Inventor. So it's more like a collaboration thing between Kodular and App Inventor that we just share features back to App Inventor in the future.
That's really cool to hear. And my next few questions are sort of about the community building part as well. App Inventor is one of the rare examples where an idea sort of was brewed in collaboration between industry and research institutions and later take on a global stage. And those things don't happen very often. It takes a lot of dedicated effort to make that happen. With App Inventor, we know there's MIT App Inventor, there's App Inventor Foundation. For the teams working on that, could you help us to understand what is the structure here? What is MIT App Inventor? What is App Inventor Foundation? How do they kind of collaborate to reinforce, to amplify each other's voice to create the impact?
Yeah, that's an excellent question. So App Inventor Foundation is a nonprofit that's legitimized and in collaboration with MIT, but separate from MIT as an entity. And that gives us a lot of affordances in doing things that may take a long time or be difficult for MIT to do. For example, global partnerships, working on collaborations with UNESCO, with ministries of education across the world, establishing programs like the Regional Appathon. So that lets us kind of take the brilliant research that the folks here are condensing into the tool at MIT and distribute it more broadly and more quickly. And of course, we also collaborate with MIT App Inventor and bring that community back here, as so many of you are joining us today.
So from my personal experience and also from what we're hearing is like university research can be really innovative, but universities themselves don't necessarily move the fastest when it comes to a lot of expanding and scaling up their impact. And that's why a lot of times we want to build scaffold around it to make it work. In terms of actually scaling up the impact, I guess question for Kelly, when you stepped into the role a few months ago, thinking about impact for App Inventor, what did you have in mind for, what did you think of impact mean in the App Inventor sense, and where are we at?
Yeah, so I think, part of the reason I wanted to work for App Inventor is because I believe it's an example of technology for good. And a lot of that is built on the goodwill of the community, the people who build into it, the open source nature of the product, the mission statement that is everybody everywhere. And I think, as I presented earlier, a lot of where I come from in my background and why I think I was brought into the foundation actually is because I'm aware of and have a deep history with the people that are the hardest to reach. So we have 30 million users. That's an amazing number. It's a free platform that anyone can use, and that's an amazing fact. But how do we build the scaffolds around it that let kids who are in situations where they may not have regular access to technology, they don't have parents who have used computers, they themselves may have low rates of literacy, or my own situation growing up, like no one had a computer to teach me on. And so we often have to figure these things out ourselves. And so to me, like the impact that we want to see is we do want to see some equity, frankly, in the usage of App Inventor. I said before that 69% of our participants in the Global Appathon come from developing and emerging markets, which is true, but we don't know who in those developing and emerging markets we're actually reaching. So part of my goal with the partnerships is to help build out programs that we know are reaching kids that would otherwise not have these types of opportunities. The platform is brilliant at introducing computer science at a level that even my 9-year-old can understand on his own. Like he's played around and done some stuff with it. So I believe that the tool is exactly what is needed. And then the second piece of what is needed is that second layer of community, not the developer community, but the implementation community. And so I'm so grateful already to our partners in Romania, Japan, India, growing partnerships in South Africa. And I'm looking really to bring, and Brazil, sorry, didn't mean to forget you guys, but I'm looking to bring that to more and more countries and ministries around the world.
And if I could add, so David Petty, where are you? Angie is also here, and so is Karen. So they're part of our education team, and they're from all over the world. So Karen's living in New Zealand half of the time, Angie's in Hong Kong, David's here, and we really take our educators very seriously. So they all have a deep background in teaching and education, and with App Inventor, we see that teachers are really the leaders in scale and in community building. So David worked really hard on this new program called the Educator Collaborative that we started 2 years ago. Oh, there he is. Hi, David. We were just talking about your work. And a lot of what Kelly and I have been discussing is how do we scale up teacher training? Because if you train students directly, a lot of them will make an app and they'll continue to do great things. But if you teach a teacher, they'll reach maybe 50 kids in year one, like 100 kids in year two, and then they'll teach other teachers. And that scale expands dramatically.
Yeah, and I'm sorry to go back and forth a bit, but really, I mean, that is, again, like the brilliance of the platform. A lot of the inhibitors with teachers is their own competencies and their own confidence. And we also see with students kind of, frankly, dangerous trends. Like the introduction of AI has in many ways, are there education researchers in the room? Anybody? Okay, like 2 of us. So just briefly, what AI has done really in education is expose flaws that we always knew were there. I don't know if you agree with me, but like assessment, the way we think about learning, what the connections are between actual human learning and education systems. And so we're really at a critical point, and it's manifesting in all kinds of different ways. There's low engagement, high rates of anxiety, depression, disengagement, even in the best places. And at the same time, you have teachers who are struggling with all of that that's happening with their students. And even lecturers at MIT and other universities have complained that students' brains are changing. The rule of the brain is if you don't use it, you lose it. And this kind of rapid fire social media kind of influx means that we're not reading longer texts. Kids are less and less willing to read an entire novel or a book or like a textbook. And so they're having to find new ways to engage. And they're losing confidence themselves. And if they already didn't have a robust computer science background, and they're being asked to teach computer science, which also happens a lot, they need tools like App Inventor to help them. And I was in Waco with David just a couple of weeks ago in Texas, and one of the teachers there was like, I have taken so many workshops on computer science teaching. I was pushed into this. It's not my field, but I have to do it. And I've never really understood what to do until today. Like now, finally, I have like concrete, actual things that I understand that I can give to the kids. And so, you know, I think the Educator Collaborative is brilliant, and I just want to see it fly. That's all.
That's so beautifully said. And we're going to come right back to the whole kind of teacher preparation, the future-facing actions. I'm very curious to learn sort of what's down the road. But also a question for Marisol as well. I think, you know, as we think about these are really cheerful and celebratory moments, bringing people together to celebrate what they have been able to create, many of which, you know, beyond what you guys initially thought they would be able to do. But we can't always just bring people to Cambridge. It's a very expensive place to bring people in. When you're thinking about kind of bringing people together in a global sense, share some story with us. Like, what have you? What are the regions that you've brought students together in, and what are some of the interesting things you've seen along the road?
It's been too many years that I've been here. Finding people from the Himalayas in 2024 was surprising to me. But I've dealt with people from pretty much everywhere on the planet at this point, since I've been running these summits since 2014. The most interesting thing is that I have, in some cases, watched people grow up coming year after year to attend these summits. They've started sometimes in middle school, high school, and now as college And as adults in their own professions, they still come back. So I think we're doing something right. We're reaching them and keeping them engaged by the work that everyone here does in education, teaching them in the development, constantly keeping things fresh, constantly listening to our users, whether they be educators or students. If they have really good ideas, and most of you do, you tend to inspire us. So as much as people think that we're inspirational because we're at MIT or we've come from MIT and we have these lofty backgrounds in some cases, these events, they inspire us. What you create, what all of the users create, that inspires us. That makes us want to do more. That makes us think about what we should do to improve. And it engages us in a whole new way, rather than, okay, I'm looking at statistics from my computer. We match it to the actual people, because we get to see the faces. We get to have those conversations, not only at these events here at MIT, but when we go out to other countries and other states, we get to engage with people, and we get to bring that back home here to our staff, and always constantly make improvements. That's the only reason that I really organize these events, is so that we can meet the people. We can then talk to each other, have these exchanges, and take it to a whole personal level. So watching people and engaging people all throughout the planet, and some very surprising locations, and some that I didn't even know they could have really good internet, it validates what we do.
Yeah, and if I could add, a new program that we are running this year is the satellite workshops, which is Marisol's brainchild. And as many of you experience, it's harder to get a visa to come here nowadays. And we can build community very strongly online, but that in-person connection is incredibly powerful, and it creates long-term sustainability. So that's why we're working with partners in Japan, in Romania, in India, and in Hong Kong to have these local workshops in tandem with the summit at MIT, so they can meet each other and feel like they're really a part of this. And hopefully we can go over there and they can come over here one of these other years.
Yeah, it's a way to build on that global community by expanding on our collaborators and having them host different satellite events.
And if there are listeners here or online thinking about wanting to get involved, is that a program that can openly inquire about their ways to stay involved, or that's still kind of incubating stage? It's
at the incubation stage, but send email to the email lists. I get them all. And I convince the people here to go ahead along with my crazy ideas.
We also have a regional appathon program that we run through the foundation. Natalie mentioned some of the countries, but if you're from a country that doesn't yet have a App Inventor regional appathon, then you should get in contact with the foundation and maybe create one.
Yeah, that's your opportunity to create something impactful for your community. I'm going to turn to the elephant in the room, which I think you guys might have discussed many times. In an era where one can create an app with one prompt, what's the value proposition of App Inventor, and how are you all seeing generative AI and this wave of AI technology as part of the future of App Inventor? Anyone?
Well, it's certainly been a topic of discussion. And at the end of the day, I think what we all recognize is that all of these things that we create are just tools, right? App Inventor is a tool, ChatGPT is a tool, Claude is a tool. The real value is, at the end of the day, what do you walk away from having changed in yourself, right? The whole idea behind computational action, as we see it, is for you to learn how to use computing to affect others in a positive way. The whole idea behind project-based learning is that you learn how to do something through building something meaningful. And just in the same way, you still have to learn how to do math before you can use a calculator, because how do you know that the calculator is right? How do you know an LLM is right? Right? And it's even harder because it's non-deterministic. You still need to have the knowledge and the ability to look at the output and really understand it. Because if you don't understand it, it might as well just, how do you actually apply it at the end of the day? I think is the real challenge. And so we think that App Inventor is a great tool for that because we have, and I think Diego will be talking a little bit later about one of his projects that he's been working on. So I don't want to steal his thunder, but if you have an app and you can look at the code for the app, would you rather look at Java, for those of us who know Java, or would you rather look at Swift for those of us who know Swift, or would you rather look at something like App Inventor? As Jose mentioned, we have a lot of interesting abstractions that make it easier for people to actually look at an App Inventor project and understand how it flows. We have the ability to translate the blocks, right? So you don't need to know English to look at somebody else's app. In fact, in our online community where we have our power users, somebody might come in and have done their entire app in Swedish, and they can the power users can look at everything in English because they prefer to look at it in English. So an App Inventor is in over 20 different languages. It lowers the barrier in a way that obviously is sort of orthogonal in some ways to what generative AI does. Because at the end of the day, if you still need to be able to look at the code and understand it. And if you don't know English, how are you supposed to look at Python code, for example?
Right. But just to play just to kind of throw out the counter argument, there are many people do drive their car without knowing how the car works. And would you say we are here for people who are interested in knowing how the car works and potentially building a kind of vehicle of their own rather than just wanting to drive one? Or are we interested in?
Well, I'll add something to that, which is that although I think that it's important, at least for some people in the future, to still sort of know how to code. For the same reason we talked about how there's a sort of cognitive loss that's associated with AI, where you don't learn what's behind what's going on, and therefore you kind of don't learn anything, right? So yes, there will be tools where you can simply vibe code apps. Some people just want the app. They don't want to understand. They don't really care about the quality of the app or whether it is maintainable in the future or a whole bunch of other things. But there's also a side of software engineering that goes beyond just the coding aspects, right? I mean, there's design, there's testing, there's specification, there's maintenance, there's efficiency, there's privacy, there's security. There's a lot of things that go on in software engineering beyond just the creating of lines of code. And a tool like App Inventor, along with appropriate curricula, can help teach those tools. And those are the tools and the capabilities that those students will use even if they're doing agentic engineering and vibe coding and building interesting, sophisticated, large apps for the future. Those are skills which are still useful today, even beyond the coding aspects.
For sure.
And I think with the Foundation's curricula, if you look at our new age responsible AI in every classroom curricula, it focuses not just on how do you make an app or code with App Inventor. It's about like social, cultural, ethical, environmental impacts of what you build. So it's a lot of like design thinking and problem-based thinking. I think with Gen AI, we're actually able to put more time in those aspects of education and computer science, which I think is more interesting to more people, and also more impactful when you go out and like create something that solves a real problem in the world. And one thing that we like to say is like, you can build any app with Gen AI, but that doesn't teach you like, should you make that app? Does it make sense based on like logic, environmental, cultural ethics? And you get that kind of intuition and knowledge by going out and trying it. So with Gen AI, they're able to do a lot more faster and more rapid cycles of iteration and learning in those real world settings.
And just add something as well. So I think that with AI, going to the analogy of the car, it's not about whether we want to just build the car or not. It's also like adding another abstraction layer. So I'm a software engineer full-time. And it's true that AI helps, but it's going to hide a lot of stuff in there. And I think that even though I code and I am a software engineer, I don't understand many of the layers below it. I just code like in Java or Python. Sorry about saying Python, but basically, we will just keep adding layers on top of layers, but we will not really understand like all the way until like the transistor level. Like we understand the basics, but we cannot really translate all the way down. So it's going to be about abstractions layer in the end.
Yeah, and just to add another story. So for the Congressional App Challenge, they run it in the US every year. I think some of the students here did that. So this year I spoke to a bunch of students who made medical apps, and they coded them with Gen AI. And I was asking about data privacy and like how is patient data hidden from ChatGPT and Gemini. And a lot of them were like, oh, I don't know, I didn't think of that. So a lot of that you can't learn by just telling ChatGPT to make a medical app. It doesn't have that knowledge of privacy and laws. You get that from interacting with a community, creating a prototype, testing it with real people, getting feedback, and doing that experiential learning cycle.
I just also want to relate this to what we saw earlier in Jerry Sussman's keynote. Programming is actually fun. Vibe coding is maybe less fun. I mean, it's fun in the sense that you get your artifact, you get your program more easily, but you're not getting the sort of joy of programming that Jerry talked about. And I was reminded of that and sort of re-inspired by that and wondering, let's bring some more of that into App Inventor, because I think that's really interesting. And not just the joy of, part of that is the joy of expressing yourself through programming. And I was reminded that one of the sort of new things we've been doing for App Inventor that maybe Evan didn't talk about, because there's a whole list of things, is integrating more debugging capabilities into App Inventor. And as Jerry kind of pointed out, debugging can be fun. So I just wanted to bring that into the mix as well.
That's a really important point, I would say. Also, Kelly, go.
Sorry. I just wanted to say, kind of from the education perspective, that this isn't a conversation that's unique to computer science. And what are the skills that we need in the future? And one of the flaws in education that I referenced earlier is that we've always measured actual learning processes by their outputs, right? How did you perform on this math test? What kind of essay did you write? What did you produce? But what we're actually interested in is the neurological processes and the connections that are built during that process. So to Mark's point, it's not just the joy of coding, it's actually the problem-solving piece that underpins all of that we want students to learn. And so the debate, as Evan said, is ongoing. We're still having these conversations, not just in computer science, but also in writing and all of these other things. And it's not unprecedented either. Before we learned to write, we could recite epics. And that is an ability no human today has, really. And we lost it because we gained writing. And so what will we lose because we have AI? What can we afford to lose? What do we need to preserve and keep? These are big conversations. But I believe that the interesting intersection between AI and vibe coding is actually that there are, and Diego may speak to this a bit later, interesting applications of artificial intelligence for educational purposes that are linked to block-based coding that can further lower the barriers to entry to these types of problem-solving skills and development. And this is something that we often talk about in education, but rarely realize. All of the research is like, yeah, maybe we could, but then it shows that we don't. So what I really want for App Inventor is to practice that, to see what the pedagogical integrations of AI-assisted coding can be that help people build not just the action-oriented kind of agency that Natalie talked about, but the actually underlying problem-solving skill sets that we really want to see.
Yes, one thing regarding to what Kelly just mentioned about measuring success by the output. So when I interview candidates, I always give them a tip at the beginning of the coding interview. That is, I don't care about the final output. What I care more is about the thought process, and I want to know how candidates think. So that's not going away, and AI is actually focused on the final result, which we actually don't care when we interview candidates. Just to add on that.
Related to what Kelly and Diego just said, it reminds me that, some of you educators, especially if you're CS educators, might remember computational thinking. And one of the tenets of computational thinking was that the ideas of coding were useful not just for creating artifacts or even for coding per se, but they're about ways that people think and the applications of computational thinking to other fields of endeavor. And problem solving was, of course, a prime example of that. So it goes beyond just the specifics of CS and coding, but into ways that you can think in all sorts of dimensions.
And the exciting thing about computational thinking is that it was essentially an addition or counterpart to what we all learned in my generation, which was the scientific method, right? And the scientific method is only applicable to very certain types of problems, whereas computational thinking is applicable to a broader range of particularly sociology problems. So we're evolving in good ways, long story short.
100%. Well, I want to focus the last part of our conversation, about 5 to 10 minutes, on the role of teachers and how do you prepare teachers, because there are so many research projects who think they build something and they put it out there in the world and people will start using it. And it turns out to be not always the case. How have you all, whether it's through gathering, through tutorial, through pedagogy, through curriculum, preparing teachers, and how is that evolving in the next phase?
Jose, do you want to talk about the classroom portal?
Well, we are working on some tools. At the foundation, we are working on some tools to make App Inventor classes easier. Like one of the main complaints that we have is that classes are very unruly. You get 50 projects at the end of the week, and they all come through your email and all those things. So we are working on ways to make that much easier for teachers. We're on beta. If you want to join in, talk to myself or David or Angie or anyone at the foundation, really.
Yeah, and David, if you want to answer that question as well, feel free to hop on a mic.
I'll also say, at least from the technical perspective, we've added a bunch of features and are continuing to add features that we hope will make instruction easier. So one of the major ones that was added a few years ago is the ability to provide tutorial URLs in projects so that you can embed as a sidebar an entire walkthrough of how to build an application. And our education team has leveraged that in all of our latest materials to provide, kind of in App Inventor assistance to the students to make it easier for them to be able to pick up and work on any given project. So that's one major thing. And then the second major thing is thinking about what are some additional tools that could help teachers in evaluating projects. So Jeanette Zemanova, who is helping us at the front desk, she is actually finishing up her MEng right now and is, so this is a plug for her. If you would like to participate in a study and you're 18 or older, she's trying to help build a tool to help to visualize the differences between two projects so that a teacher could look over time and see how a student is developing a project as part of their project-based learning curriculum and see that the student is actually gaining new skills or reworking their project in interesting ways. Maybe they refactor to add some level of abstraction that they didn't have before, and then the tool kind of helps the teacher visualize that. And so we're really excited that we're able to try to build these types of tools into App Inventor to make it easier for teachers to do evaluation in the future.
For teachers, say, watching our discussion right now, who has not been part of the community, and they might potentially be intimidated, be saying like, oh, I need to review this product. If I'm a teacher thinking about adopting App Inventor in my classroom, what should I be aware of? Like, what should I know before I can say, oh, let me bring App Inventor into my classroom? Like, does the teacher have to be, I assume they have to be good at programming themselves to be able to...
No, I don't think that's true. And I'll quote sort of our work with the Hong Kong Jockey Club over the last 8 years. The curriculum was developed by Josh Sheldon and Karen Lang, and then eventually Celine joined, and then Robert has been helping with the latest round of that. And the initial batch of teachers who taught that curriculum were English teachers in Hong Kong. And part of the reason for that was because the math teachers didn't know English, and the curriculum originally was in English before it was translated. But at the end of the day, you have to really think about, especially with generative AI now, we weren't thinking about that back then, computing is a part of our lives these days, right? Like nothing that we do isn't really kind of touched by computing in some way, and now it seems to be that that's going to be true of generative AI. So we need to know how to apply this set of skills in every domain, right? Whether that's, okay, my student has created an essay with generative AI, can I at least get them to understand how to edit the essay or make changes? Because if it's about expressing their ideas, they still need to be able to do that skill. They can't just keep asking, I mean, they can just keep asking the AI system, but you would hope as a teacher that you would teach them that that's not necessarily the best way to do it, that there are other ways of approaching the problem. But that's going to be true of every field, right? And so you don't need to be a programmer to pick up App Inventor. You know, a 10-year-old kid or a 9-year-old child picking up App Inventor, they're not a programmer by definition, right? Like if it's their first time using this tool and they're not a programmer, the whole point is that they have to develop those skills. And similarly, as a teacher, you're going to develop those skills as well. So.
There are lots of resources too, I would just say, because I'm also not really a technicist. So when I joined App Inventor, one of my jobs was to learn App Inventor, and the tutorials that are available, the walkthroughs, the sidebars, you can learn a lot even without any help. So I think we've seen very low capacity teachers pick that up really quickly and see that they can create something really simple themselves very quickly and build on their skill sets from there. So it's a really excellent tool.
Yeah, one of the things that I think the sort of AI revolution has done for App Inventor is it's sort of made us double down on the education side and the connection with teachers and education. Because the idea, one of the original ideas of App Inventor was just to make it as easy as possible to build mobile apps.
Right.
Well, vibe coding and agentic engineering have I think they're going to take over that part of it. But there's still the education part. And I think that is sort of the future of App Inventor. And I think we've all kind of come to recognize that. And that's going to infuse everything we do and have been doing for a while and will continue to do. So, we definitely have a strong motivation to keep up with our teachers and educators.
Great. Well, I think that's a great way to end our panel discussion, to think about the future of App Inventor and its role in providing this kind of educational experience that is empowering and enlightening to both educators and learners across the globe. And with 30 million users now, we look forward to have it 300 million users or more than that. All right. Thank you very much, everyone.